All right, section 14.2, we're going to focus on machines. All right, and how does a machine work and how do machines make our lives easier? So if you think about what does a machine do for you? A machine typically makes something easier to do. And what a machine does is it changes the force. Typically, all right, if you look at a simple machine like a wheel or a lever, all right, how does that make things easier? It reduces the amount of force that you have to put on something to get something done. So a machine is something that's going to change the force. Now there are tons of machines, and we're going to talk about them in the next upcoming chapter. But what we're going to dive into mathematically is how machines work. Now, how machines work is a complicated process, and we're going to have some vocabulary that we're going to have to hammer out along the way. So, with that vocabulary, what we're focused on is, since we're talking about work, what is work again? Work is force times distance. So a machine is going to do one of two things. It's going to reduce the force or reduce the distance, or it may do both. So we have to study force and distance. So work input, right, is the force exerted on the machine. That's the amount of force put in by the person. All right, can't iterate that enough. The work input, right, is the force exerted on the machine or the force put in by the person. Right? Work output. All right. Oh, sorry, jumped the gun here. Input distance is the distance the force acts through. So again, that's the distance the person moves the device. All right. So if you could think of this as a bottle opener. All right, a bottle opener. Your input force is the amount of force that you're applying down on the lever. The input distance is the amount of distance you're moving the lever. All right, think of that. So we have work, we have input force and input distance. Pretty much in is the person. We're going to clarify that as you are the in person. All right. Typically when you do a machine, it's you and the machine. Work input is the work that you put in. All right. So that's the force times the distance. Now, output, all right, that's the force exerted by the machine. In was the person, out is going to be the machine. All right. All right. So when we talk about work output, we're going to talk about distance. That's the distance the machine moves. Right, or the machine applies. Work, that's the amount of force and distance the machine applies. Okay. So two things here. In, whether it's force, distance, or work, is the person. Out, whether it's force, distance, or work, again, it's still the machine. So in, whether it's work, force, or distance, the person. Out, whether it's work, force, or distance, is the machine. And what we can do is we can take our knowledge of whether it's input or output, and we can actually figure out how good the machine is working for us. Right? Because you guys have all used machines before that really don't do much, and you've all used machines that have a lot of benefit to you. So if we go back to that example one more time, in is what you do. So if I'm opening a bottle with a bottle opener, all right, the work that I am doing is moving the bottle opener down. The work that the bottle opener doing is applying that work to the cap. So my input would be my hand pushing down. The output would be the lever opening the bottle cap. Just to clarify. So when we talk about this, we get three equations that we can talk about. Mechanical advantage. Right? How much advantage is the machine giving us? And I'm just going to abbreviate mechanical advantage, MA. Right? Mechanical advantage is equal to output force divided by input force. Mechanical advantage has no units. All right. And why is that? Well, what's the unit for force? Newtons. What's the unit for force? Newtons. Newtons divided by newtons cancel out. So when we talk about mechanical advantage is equal to output in force divided by input force. All right. Mechanical advantage, force out divided by force in. Or if you wanted to do this, machine divided by the person. Right. The machine divided by the person. So that's mechanical advantage. Next, we have ideal mechanical advantage. Now, here's the thing that becomes tricky, is every machine is not 100% efficient. If you could invent a machine that's 100% efficient, you'd be richer than Bill Gates. And the reason machines aren't 100% efficient is we have friction, we have heat, we have air resistance, we have all these things that slow down the process. So no machine is 100% efficient. Think about your car engine. Your car engine is not 100% efficient. As much as you would like it to be, it's not. You're always going to have to put in more work than you get out usually, but it's still nice to get some work in return. So what we're going to use ideal mechanical advantage is in a perfect world, which does not exist, because we have friction, we have heat, we have air resistance, we have everything that can slow down the process. In a perfect world, if we didn't have those things, how well would this machine function? And that's ideal mechanical advantage. And ideal mechanical advantage is IMA, and that's equal to input distance divided by output distance, or person divided by machine. So ideal mechanical advantage, input distance divided by output distance. Very critical, very crucial. Last thing here is efficiency. I want to know how well a machine can work and how efficient that it can be. Well, I just told you that not all machines are 100% efficient. Well, why is that? It's because of friction and heat and air resistance. But if I want to figure out how close to 100% a machine is, I'm going to take its efficiency. And its efficiency is work output divided by work input and multiply that by 100. And when you get the reason you multiply by 100 is because you always want that as a percent. When you just do work output divided by work input, you're going to get a decimal. So work output is the machine divided by the person. The work done by the person. And we'll kind of continue to talk about work output, work input, force output, right, distance input, distance output. But the biggest idea here is that all our input force is usually done by the person. All of our output force is done by the machine. And when we do that, we can solve for how well a machine is working through mechanical advantage, ideal mechanical advantage, and efficiency. And we will practice with these some more in class tomorrow. This is Mr. Clement, and I'm signing off.